Hello everyone, welcome to solve this math Olympiad algebraic challenge, and here we have a plus 5 whole cubed plus a plus 3 whole cubed equals to 8, and here we find the value of a. So the very first step we are going to do is here first we rewrite this equation as we have a plus 5 whole cubed, and we write it as a plus 4 plus 1 whole cubed, and plus we write this a plus 3 as a plus 4 minus 1 whole cubed equals to 8. So in the next step, you see here we have a plus 4 be the common expression, so that we will take this a plus 4 equals to y, and we write it as y equals to a plus 4. So when we put a plus 4 equals to y, so the above equation will be written as y plus 1 whole cubed plus y minus 1 whole cubed equals to 8. So in the next step, you see here we need two cubic formulas. So I can write it here. First we use a plus b whole cubed. We know that it is equals to a cubed plus b cubed plus 3 times of ab into a plus b, and the second cubic formula is a minus b whole cubed, and it is equals to a cubed plus minus b cubed minus 3 times of ab into a minus b. So these are the two cubic formulas we need here. So now first we use the positive cubic formula on this one and the negative cubic formula on this term. So now first we use the positive cubic formula, and we know that y plus 1 whole cube equals to y cubed plus 1 cubed plus 3 times of y into 1 into y plus 1, and plus here we use the negative cubic formula, and it will becomes y cubed minus 1 cubed minus 3 times of y into 1 into y minus 1, and this whole equation equals to 8. So in the next step we need to simplify these terms, and here we have y cubed plus, we know that 1 cubed becomes 1, and we multiply this 3y to both of these terms, and we get here 3 times of y square plus 3y, and here we have this y cubed, and we know that 1 cubed becomes 1, and we multiply this minus 3y on both of these terms, and it will be written as minus 3y square plus 3y, and this whole equation equals to 8. So here we need two more simplifications here, and now you see that we have this is the plus 3y square, and this is minus 3y square are cancelled by each other, and this is plus 1 and minus 1 are also cancelled by each other, and we get y cubed plus y cubed, it will be equals to 2 times of y cubed, and we have 3y plus 3y becomes 6 times of y, and we move this 8 in the left hand side, and it will becomes minus 8, and this whole equation equals to 0. So in the next step, you see here we have to be the common expression on each term, so that we divide both of the sides by 2. So when we divide both of the sides by 2, then after simplification we get here this 2 is cancelled out by this 2, and we get here y cubed, and plus this 2 is cancelled by this 6, and we get 3y, and these 2 4s are 8, and we get minus 4, and this is whole equation equals to 0. And in the next step, here we get this cubic equation, and now we break this cubic equation, and we easily get the factors of this cubic equation. So here we break its middle term, and we write it as y cubed, and we have this 3y, and we write it as minus y plus 4y minus 4 equals to 0, because minus y plus 4y equals to plus 3y, and now we take common y from the first two terms, and we get here y times of y square minus 1, and here we take common plus 4, and we get y minus 1 equals to 0. So in the next step, you see here we have y square minus 1, and we know that y square minus 1 equals to y minus 1 times of y plus 1 plus Here we have 4 times of y minus 1, and this whole equation equals to 0. So in the next step, you see here we have y minus 1 be the common factor, so we take common y minus 1 and we get y times of y plus 1 plus 4 equals to 0. So here we need a little bit simplifications, and we can multiply this y on both of these terms and we get y square plus y plus 4 equals to 0. And now in the next step we convert this case in two parts. So our first case is we write this y minus 1 equals to 0, and the second case is we write y square plus y plus 4 equals to 0. So in the first case we easily get the value of y equals to 1, and in the second case, in order to find the values of y, first we check that this quadratic equation has real roots or not, because in this problem we need only real roots. So that we use the discriminant formula in order to check the roots of this equation. So first we write the coefficients of this equation, and the coefficients are a equals to 1, b equals to 1, and c equals to 4. And we know that the discriminant formula will be looks like delta equals to b square minus 4 times of ac. So here we put the values of a, b, and c, and we get 1 square minus 4 times of 1 into 4, and it will becomes 1 minus 16, and we know that 1 minus 16 equals to minus 15, and it is less than 0. So the discriminant formula, so we know that if the value of this delta less than 0, it means that this quadratic equation has no real root. So if this quadratic equation has no real roots, then we will rejected this case and we can just proceed here this case only. And in this case we have the value of y equals to 1, but in the start of the problem we will take here our y equals to a plus 4, and now we back substitute the value of y and it will becomes a plus 4 equals to 1, and we move this 4 to the right hand side and it will becomes a equals to 1 minus 4, and finally we get the value of a equals to minus 3. So now we check or verify the value of this a, so that in order to verify this value a equals to minus 3, we copy down the given question statement. So our given question statement is a plus 5 a plus 5 whole cubed plus a plus 3 whole cubed equals to 8, and now we put the value of a, it is minus 3 on the left hand side, and it will becomes minus 3 plus 5 whole cubed plus minus 3 plus 3 whole cubed equals to 8, and here you get minus 3 plus 5 becomes 2 cubed, and this is the 0 cubed equals to 8, and we know that 2 cubed equals to plus 8 and 0 cubed is 0, and 8 plus 0 becomes 8, and in the right hand side we have 8. So this shows that a equals to minus 3 satisfies the given question statement. So a equals to minus 3 be the only solution of this problem. And this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.